Hello everyone. Now we'll do the question number 14. The binding energy of nucleons in a nucleus can be affected by the pairwise Coulomb repulsion. Assume that all nucleons are uniformly distributed inside the nucleus. Let the binding energy of a proton be EBP, that is the binding energy of proton, and binding energy of neutron is given that EB, binding energy of neutron N in the nucleus. Which of the following statements are correct? Now they have given that pairwise Coulomb repulsion. See, in nucleons we can see that if you take any nucleus, in nucleons there will be neutrons as well as protons, neutrons, protons, like that will be there. So here the electric repulsions will be there between proton and proton only. There won't be any electric forces between the neutron and proton and neutron. So electric only repulsive forces between repulsive forces are between proton and proton. So and whatever the nuclear forces are there, nuclear forces between proton, neutron, proton, they are same. So whatever energies are there, that we can take the same reactions we can write. The Coulomb repulsive forces are actually between proton and proton will be there. Now if you see that binding energy due to repulsive forces is only due to the proton repulsive forces only. Neutron, anyway there won't be anything. So binding energy of the proton, neutron, proton is same. So we can see that whatever electric repulsive forces between proton pairs, actually there will be, you can see that ZC2 pairs. There will be ZC2 pairs, Z into Z minus 1 by 2 pairs will be there. We can write that forces is in form of potential energy only. So that potential energy can be written as we can write like a Z into so between this ZE into Z minus 1 into E divided by the 4 pi epsilon naught into capital R. That is binding energy of the protons minus binding energy of the neutron. So this neutron value is 0 only. So we can write the value is proportional to, we can see that it implies EBP minus EBN is directly proportional to Z into Z minus 1 divided by the R. You know that radius of nucleus is you can write it as R is equal to R naught a to the power of 1 by 3. We can write Z into Z minus 1 divided by R naught into a to the power of minus 1 by 3. Now according to the question, we can see this value is Z into Z minus 1, where the Z is atomic number of the nucleus, that is correct. And EBP, binding energy difference here, is proportional to a power minus 3, so that option also correct. EBP minus EN is positive, this is wrong. Okay, always EBP value is more than the less than the EBP is less than EBN, neutron having more mass as comparatively proton. EBP increases if the nucleus undergoes beta decay emitting a positron. So if it is emitting a positron, beta decay, in beta decay process what will happen? In beta decay process proton number decreases. If proton number decreases, then we can see electric repulsive forces between proton decreases. Repulsive forces between proton decreases. If electric repulsive forces decreases, we can say that whatever binding energy is there, that binding energy of the proton will be increases. So we can say option D is correct. According to this above relations, we can observe that A, B, D are correct options. I hope